Hello, my name is Ethan Orban, and today I'm going to be talking about computer networking through math application and its history. Firstly, I'll start off with the history of computer networking and programming. The origin of the Internet can be traced back to the U.S. Advanced Research Projects Agency, ARPA, which later became DARPA. In the late 1960s, ARPA developed an early packet switching technology, the Advanced Research Projects Agency Network, ARPANET, which ultimately led to the invention of the Internet Protocol IP suite. Typically referred to as TCP, the protocol is the foundation of today's Internet. Xerox is the company that can lay claim to the invention of Ethernet. In 1973, at a Xerox research facility in Palo Alto, California, Robert Metcalfe and David Boggs built the first Ethernet prototype that operated at 2.94 megabits. After performing further testing, Xerox eventually patented Ethernet in 1975. In 1979, the IEEE came into the picture when it formed a standards committee around Ethernet with the purpose of promoting the technology for mass consumption. Contrary to popular belief, the invention of the router predates Cisco systems. The networking breakthrough originated with the Interface Message Processor, a gateway device used in ARPANET. The multi-protocol router was developed in the 1980s by Bill Yeager, a researcher at Stanford University. Stanford IT staff Leonard Bosack and Sandy Lerner realized that the commercial implications of the router technology and developed a revised version of Yeager's router and went on to Cisco Systems in 1984. Because Ethernet technologies operated using CSMA/CD media access control, it limited the number of devices that could attach to a LAN, or local area network, and remain functional. To combat the increase of broadcast traffic on LANs with a large number of connected devices, the concept of a virtual LAN, or VLAN, was developed in the late 1980s and early 1990s. This technology logically segments a single LAN with a single broadcast domain in two or more logical LANs, each with their own broadcast domain. Later, the IEEE 802.1q standard was developed to standardize VLANs and the trunking of multiple VLANs over network uplinks. Who invented the firewall? Well, that seems to be a question we may never truly be able to answer. What we do know is that the firewall has been the first line of defense in enterprise networks for the better part of 3 decades. Original firewalls were stateless in nature, which meant that access control rules had to be created in both directions. Check Point Software Technologies, founded in 1993, is said to be the inventor of the modern stateful firewall that is still used today. Check Point's network firewall ushered in an entire market of networking tools and appliances that focus solely on the protection and integrity of data as it flows across trusted and untrusted networks. 802.11 technology, or more commonly referred to as Wi-Fi, which you and I all know, was almost certain to be an enormous success no matter what. However, it was Steve Jobs that played a pivotal role in making wireless technology so popular so quickly. At the Macworld 99 conference, Steve introduced the original iBook and airport wireless technologies. While the iBook had a whole host of computing innovations, the one that stole the show was how it could be networked effortlessly using Wi-Fi. And just how did Mr. Jobs choose to show off the innovative new technology? Well, with a hula hoop, of course. Back in the late 1950s, it was not clear to most engineers and practitioners that data communications were fundamentally different from voice communications. Not only were these differences unrecognized by most, but also in those cases where they were not recognized, the conclusion was that it did not matter because data transmission was of no interest relative to voice transmission. Today, the differences are understood, important, and of such significance that current packet switching networks are seriously threatening the business viability of the 100-year-old voice communication telephone networks. Voice communication uses a technology called circuit switching, which requires that a dedicated path of network resources be set up and allocated between the two communicating parties. These resources are dedicated to this voice communication during the entire call, even if nothing is being spoken by either party. With speech, there is silence on the line approximately 1/3 of the time, and this inefficiency has always been tolerable. However, the nature of data communications is considerably different. Data is inherently bursty in that it occurs in short bursts of communications followed by long periods of silence. The ratio of silence to communication can be as high as 1,000 to 1 or even 10,000 to 1. And this inefficiency in the use of networking resources is totally intolerable. I chose to model a data network as a network of communication channels whose purpose it was to move data messages from their origin to their destination. Each channel was modeled as a server serving a queue of data messages awaiting transmission. The main metric I used for the performance of the network was T, the average time it took for messages to move across the net. Under extremely general conditions, I was able to show that this mean delay is given exactly by the following equation. Sigma of lambda over gamma multiplied by T. Now I'm going to move on to the mathematical significance of computer programming. Computer programming touches almost every aspect of our lives. Software applications for our computers is commonly thought of when computer programming is mentioned. However, programming of embedded devices can be found in cars, cell phones, video games, appliances, and door locks. Computer applications are available for education, entertainment, and work that uses different types of mathematics. Firstly, basic programming math. Binary math is at the core of how any computer operates. Binary is used to represent each number in the computer. Reading and simple mathematical operations with binary is critical for low-level programming or hardware. Understanding how to work with hexadecimal number systems is required for many programming functions, such as setting the color of an object. Standard arithmetic is used in many functions of programming. Addition, subtraction, multiplication, and division is used in almost every program written, mostly in JavaScript. Algebra is used to solve simple problems that many computer programmers will encounter. Advanced programming math. Obtaining a computer science degree requires completing many math classes. These include college algebra, statistics, calculus 1, and calculus 2. These cases and classes are applied in two different ways for computer programming. The most obvious is using the math taught to solve complex equations, but the less obvious is skills learned to master advanced math is similar to the skills required to build complex applications. These skills include logic and following complicated step-by-step processes. Application-specific math. The application for the program being created will often dictate the specific type of math techniques required. Linear algebra is often used for transformation of matrices. Matrix transformation is found in both 2D and 3D modeling, as seen in computer-aided design and photo editing software. Differential equations can be found in software to simulate traffic or health conditions. Statistics is used in many computer programming applications, including polling systems, reports, and card games. So, what have you learned today? Well, You have learned the historical background of computer networking and computer programming. You have also learned the application of mathematical concepts and what they are used for in programming and networking. We all use the internet and computers almost every day, from home computers to school laptops to cell phones to any other electronic device you get on. Networking and programming is involved, and so is the math that goes along with it. I hope you've enjoyed today's presentation. Please leave a like or subscribe to my channel. Thank you.